Hello and welcome. This is James Green of Uber Solar, and the subject of this video recording or Zoom meeting is: what size of solar water heating system do you need? I'm going to use a whole number of slides to assist me here, particularly as some of it's a bit technical. I apologize up front for any technical glitches. But we will start sharing now with luck. And with a bit of luck, what you're seeing is what size of a solar system do you need and why. And there are a number of examples here of 18 tube systems, 24 tube systems, 30 tube systems, and 36 tubes. And you can see at the top highlighted in yellow the number of people that they can basically service. So typically for 2 to 4 people, we never go really smaller than 24 tubes, which is 7.5 kilowatt hours, which is the amount of electricity which is consumed heating a single tank of 150 liters. And what you'll see on the slide is not only the number of people, the number of tubes and the amount of kilowatt hours. You'll then see a photograph of the tubes with the PV panel, and then you'll see 150 liters. Now, typically, that will be a retrofit or a complete system. A retrofit is where we connect the solar system to the geyser in its existing location generally. Sometimes we move it. We then tell you how much hot water the tap is likely to give you, which in this case is 276 liters. And we'll also tell you how many minutes showering at a typical high pressure shower rate that will give you. We also tell you the efficiency of the system in the replacement of the electricity. So we have that for every side. So when you're looking at the various different sizes of people or the number of people, that is the criteria. And as we go up, we, on this slide, have 4 to 5 people, and that right up here at 7 to 10 people, where you can see there's a very big solar collector, 78 tubes. And at this stage, we're talking about 927 liters of washing temperature and 600 liters of storage. But exactly the same principle. So what we're going to do now is to explain how we get there. And I want to emphasize that you don't need to remember all of this technical stuff. It's a situation of understanding the basic science to understanding how big a solar system you need. And the criteria that are needed for understanding is the amount or volume of water and the temperature of the washing water at 40 degrees, which is the temperature which most people wash at. Girls, not quite as hot, 39. That's because they're hotter than us boys. Hotter chicks. And we'll start with an example. A shower, a typical high pressure shower, will use around 15 liters of water a minute. Low flow shower head will be about 10 liters. Large rain flow shower head is about 30. And 36 liters of water will consume about 1 kilowatt hour of electricity. And therefore, with a typical high pressure shower at 15 liters, about 2.5 minutes in the shower will consume 1 kilowatt hour of electricity, and the total number of minutes washing in 24 hours determines with around 90% accuracy the amount of electricity consumed heating water. In looking at that simple example and looking at money, it's interesting, it works out to just over 1 rand for every minute that you spend in the shower on the cost of electricity. Now, again, you don't have to remember this, but it's a useful formula. The specific heat of water formula is everything has a specific heat. And in terms of water, you can calculate it by taking the volume multiplied by the temperature differential, which is the difference between the cold and the hot. And you divide that by a constant of 860, and that will give you the number of kilowatt hour units consumed. Again, you don't have to remember it, but it's a useful thing. And what that basically means is that if you're heating 100 liters tank, 100, which is not many, there aren't many 100-litre tanks, is going to be just over 5 kilowatt hours. 200 litres is going to be just over 10. 300 litres is going to be just over 15. And likewise, if you're looking at washing temperature, 1 kilowatt hour will heat 36 litres. And people ask why age 60, it just happens to be a magic constant formula to make life easy rather than the long-winded exercise of joules or kelvins. Comes out the same answer. So, back to basics, really. Electric geysers. It may be simple, but an electric geyser will heat up every time the thermostat drops by 5 degrees. That basically means you turn on the hot water tap. If you take 5 litres out of it, it's going to drop because cold water is coming into the geyser. And when somebody has a shower, the hot water from the geyser may be coming out at 50, 55, even 60, and it's going to be mixed with cold water at, say, 15, 20, and the temperature, just like is going to fall in exactly the same way as adding cold milk to a cup of tea. And the geyser is going to cool as the hot water is taken out. And the more hot water is taken out, the more the temperature will drop, and the electric element will kick in when the temperature has dropped by 5 Celsius and will continue heating the geyser until it gets up to the thermostat temperature. And the long and short of that is that most geysers will heat up more than once in 24 hours. If it's a 150-litre geyser and you're a 3 to 4 person home, the probability is that your 150-litre geyser will be heating up nearly twice every 24 hours, and that means around 12 to 15 kilowatt hours just on heating water. And generally, hot water heating is between 35 and 60% of your domestic electricity bill. Now, when you come to solar, there are a whole number of considerations. First of all, a solar obviously only works during the daytime, and that's typically an 8-hour period, but the peak heating time is around 5.5 hours. And of course, it is dependent on the weather and the levels of solar irradiation during that day. Now, if looking at the consumption of your water, if all the solar hot water is used up in the evening, when you get home or whatever, your geyser is going to be cold unless you're going to have electrical backup to heat up to guarantee that you're going to have hot water in the next morning. So it's very difficult not to have some form of electrical backup to guarantee that you've got hot water. And the two have to be done in harmony. And therefore, you have to look very closely at the solar system and the output of the solar system in kilowatt hours to determine how much hot water you're going to have. So, how much do you have? We've done the electrical exercise. So, again, you don't have to remember all of this, but if you take the deemed kilowatt hours, it's going to be able to, you're going to be able to calculate the amount of hot water you have at the tap and how much water you have in 24 hours. So if you have 10 kilowatt hours, which is going to be around 30 tubes in this case, it's going to be around 360 litres of hot water at 40 degrees, which if you divide it by 15 is going to give you around 24 minutes of continuous showering. That's continuous. If you're going in and out, it's going to be less than that because the system is constantly going to be diluted. So, how do we advise you on what size of solar system you need? Basically, it's down to years of experience and just referring to the science and human washing behavior. If you tell us that the people in your house bath rather than shower, we're going to tell you you need a much bigger system. If you shower twice a day, like I do, you may well need a larger system. If you spend 12 minutes in the shower or 20 minutes, you're going to need a bigger system than somebody who spends 3 minutes. So it's really a question of down to science. And if you look at the graph, we have an average range of expected electricity consumption. We know that the typical amount of consumption is between 85 and 125 liters of hot water per person per day. That's 40 degrees Celsius temperature, not geyser temperature. We know that in various gyms, they will use far more hot water than in other types of gyms. We know that in the mines, they may stand under the hot water tap for half an hour and use 250 liters. So at home, it's a question of actually looking at what you need. And we go back to the first pictures of where we were looking at not only the size of the tanks, but the amount of hot water which we have here, 207, 276, 346, 414. It sounds like a lot, but the reality is you frequently need more hot water. So, in summary, how big? Almost always bigger than you expect. And as a guideline, it's difficult to have too much hot water and easy to have too little. And it's better to get it first right, but with our technology, it is plug and play, so you can always add to it. The next steps are to get a quote from us, call us or chat to us on WhatsApp, visit the website, email us, and watch some more videos. I would like to, in conclusion, thank you for listening to this rather technical thing, but if you've got the basics, you'll understand that it actually is quite straightforward. You don't need to remember all the science, but it's useful to have it there as background. We will advise you on the size of system that you need. And if you give us the information, it's easy for us to do, but this enables you to go and work it out yourself. So thank you very much for listening. We look forward to seeing you on another of our videos, and most importantly, education is key to avoid mistakes. Thank you very much.